This video is on single replacement reactions, sometimes also called single displacement reactions. I mean, replacement and displacement are the same thing. So kind of the general idea or format is this is a compound will react with an element and produce a different compound and a different element. So I wouldn't write down that sentence right there the way it's written. I would kind of write more a general format. So if you take a compound, and here's my abbreviation, and you react it with one element, what you're going to make is a new compound because that element is going to come in and switch places with part of the compound. And you're going to make a new compound and you're going to have a different element. So you'll see this written a couple different ways in a general format. So in this first one we have ax plus y. And then you can see how it turns into ay plus x. So the y and the x switch places. And the reason those two particularly can switch places is because they're the same charge. So for this one, A would have to be a positive charge, your cation, and X would have to be your anion, the negative charge. Remember, because the cation goes first. So if Y is switching with X, that means Y is also negative. So this could also happen in this second one. We have AX plus B, and that turns into BX plus A. And in this case, we can see that B and A switch places. So A has to be positive because it's first, and X is negative, your anion, and that would make B a cation. So that's why B and A are able to switch, because they are the same charge. So when you see, right, the metals or the positives are switching charges, and then when you can see the negatives are switching, those are nonmetals like A and X. All right, so one element up there, like we just talked about, displaces a similar element. So that means, like we were just talking about, a metal replaces a metal, or a nonmetal replaces a nonmetal. And what we look at is called the activity series. Oops, that's not what I wanted to do. We look at the activity series to determine if this is actually possible. So you are going to see or get this activity series on what we call your blue sheet. And if you haven't gotten this in class, you will. But you'll see this list on the back. And so what you'll see on this list is elements on the top, like it starts out with lithium, and then it goes into rubidium, and then potassium, barium, strontium, and so on. And what this means, it's in decreasing reactivity. So lithium is the most active, and they get less active as you go down. So an element on here can replace any element below it, any element that is less active. So lithium can replace any element. However, like strontium, for example, cannot replace barium, potassium, rubidium, or lithium. So these are your metals on the activity series. The halogens, these are just in decreasing order. So the same kind of list we just talked about with the metals, but they're in order that they are on the periodic table. So these go from fluorine to chlorine to bromine to iodine. And fluorine is the most active, so it can replace anything below it. So chlorine, bromine, and iodine. And then again, it goes down where it's less active as you go down the list. So I'll show you what I mean when we go through some of these examples. All right, so we have here iron sulfate plus zinc. So single replacement because I have an element in my zinc and I have a compound in my iron 2 sulfate. So what I want to look at here are the charges. So my iron is my cation and my sulfate is my anion, and my element, my single element zinc, is a cation. So what I'm predicting is that zinc will try to replace the iron because they are both cations. So what I have to do is I have to look at my activity series. For this to happen, I'm going to make a little note. To react, zinc needs to be higher or more reactive than iron. So if I look at that activity series, and you should have this hopefully on your blue sheet, I find zinc kind of in the middle there, and iron is 2 below it. So that means this will happen. So then what I'm going to do is I'm going to actually figure out their charges, and zinc is a +2. Iron in this case is 2 because sulfate is -2. So when I replace zinc with iron, now I'm going to put zinc as a +2 with the sulfate as a -2, which would give me a formula of ZnSO4, and iron gets kicked out. And this is actually already balanced. All right, if you'd like to try the next one, that would be great to be prepared for class, and we'll go over that one in class. But let's jump down to number 3. All right, so let's do the same thing. So let's look at charges. So hydrogen is my cation, fluorine is my anion. Bromine is an anion. It's negative, it's a nonmetal. So here I have to look at that list of halogens. So I wrote that in red right above. And bromine needs to be higher than fluorine in order for this to react. And you can see bromine is lower. So that means this will not react. And so what we do is we write NR for no reaction. So this one, there is literally nothing else to do because nothing happens. All right, so why don't you give D a try, and we'll talk about that in class as well. So that is single replacement reactions. Write down any questions you have or anything so we can discuss them in class.